Hey guys, this is your notes on mass, weight, and normal force. Alright, so first we're going to talk about the difference between mass and weight. So why don't you write down the definitions. You can pause the video if you want to do this for a sec. The definitions of mass and weight. Alright, so mass, represented with an M, it's the amount of matter in a substance. Okay, unit, kilograms, or grams. Weight is either represented with a W, capital W, or Fg, representing the force of gravity. And the definition of weight is the force of gravity pulling an object towards the earth. So weight is a force, while mass is not a force. All right. The unit of weight is newtons because it is a force. And weight has an equation where you can calculate weight as well. Fg, that's weight, equals mass. So if something is more massive, it has more weight also. And you can multiply the object's mass by acceleration due to gravity on any planet, and you get its weight. So on our planet, acceleration due to gravity, we represent that with a little g, is 9.8 meters per second squared on Earth. So if you multiply that by mass, you get weight. Alright, so mass and weight, they're commonly confused, so we need to go over the difference between them, right? And the difference is gravity causes the difference, really. On Earth, say I have a rock, the mass of the rock is maybe 10 kilograms. And on Earth, gravity pulls it down. You could feel it in your hand when you hold a rock that it applies pressure to your hand. That pressure is due to the fact that the rock has weight. It's being pulled down by gravity. Gravity is exerting an Fg, a force pulling it down. Alright, now if you take that rock to another planet, the moon, the amount of matter in the rock is the same, so it has the same mass. That doesn't change based on location. But when you hold the rock, you would experience a smaller weight. That's why I drew a smaller arrow in Fg, smaller Fg. The rock would not exert such a great pressure on your hand on the moon as it would on Earth. It would appear to weigh less, even though it contained the same amount of matter. That is, it had the same mass. Alright, so here on Earth, maybe the weight ends up being about 100 newtons. Here on the moon, it ends up being like weighing less, 20 newtons of weight. Newtons and pounds, pounds and newtons are basically, a unit for weight. Because both are a unit of force. In space, however, say you're in deep space, I don't know why I drew ground there, the rock still has the same mass. The mass of the rock never changes unless you were to, somehow throw it at a wall and it broke into pieces. But when you bring it to a new location or planet, and the amount of matter stays the same. However, now the weight, there's no planet underneath you, so you would not experience any pressure on your hand from the rock. It would appear to weigh nothing at all. So when there's no gravity, objects have no weight. Let's do an example problem with mass and weight. A watch weighs 20 newtons on Earth. What is the mass of that watch? So let's use our weight and mass equation there. Fg equals mg. And if the watch weighs 20 newtons, what that is that's the force of gravity on the watch. And they want us to calculate its mass on Earth. So because we're on Earth, we can use 9.8 for the acceleration due to gravity. And then divide both sides by 9.8, and you have its mass. And the mass will be, you could do it on your own, 20 divided by 9.8, 2.04 kilograms. Alright, so what's the weight of the watch on the moon, though? Well, on the moon, g, the acceleration due to gravity, is not 9.8. On the moon, g moon equals 1.6 meters per second squared, a little less. So how much would the watch weigh on the moon? Well, we know when we bring the watch to the moon that mass doesn't change. It's still the same amount of matter in that watch. So we can use that mass we just calculated and the acceleration due to gravity on the moon to get its weight on the moon. Three point 3.26 newtons, much less. Switch to pen. Alright, so that's the weight of the watch on the moon. Same mass, different gravity, different amount of gravity. What is the mass of the watch on the moon? Well, this is not a trick question. It's just very straightforward. No matter where you bring that watch, if it's the same watch, it's going to have the same mass. Alright? So sum up mass and weight and their difference. Weight is a force of gravity. You could feel it press on your hand when you hold objects. So it depends on location. Mass is not affected by location or what planet you're on because that doesn't change the amount of matter in a substance, alright, or in an object. But gravity affects how much pressure an object could put on your hand and how much it's pulled down. That is its weight. Weight is a feeling, and therefore it is a force.